whole number. Perfect. Okay, so we can do that. We can do that. So now that we have the basics, we know that, and I'm going to write this big because I don't want you all to mess it up. Time is on the x-axis. Height is on the y-axis. Remember, time is always independent. Independent. Okay? All right. Now that we have that firmly ingrained into our memory, let's use our graphing calculator. So we will take this data and we will put it into our calculator, and what we're going to do is we're going to press Stat, then we're going to use option number 1 that will appear up here, which will say Edit, and then we will put in our values. So let's go ahead and do that. Okay, so I'm going to clear these. I'm going to clear those out first. Okay, Stat. So I press Stat, now I'll press Edit. Now let's put in our values over here. 0, 0.5, 1, 1.5, 3, 4.5. Let's come over and put in our dependent variables. 42, 44.5, 46, 46.5, 42, 28.5. Very good, very good. So let's find the regression equation. To find the regression equation, what I'm going to do is I'm going to press Stat, then I'm going to arrow over to Calc, then I'm going to go all the way down to option number 5, which says Quadreg. So that's where I'm going. Stat, Calc, number 5, which is Quadreg. Then I'm going to hit Enter. So let's do that. So I will press Stat. There's Calc. Just arrow over to Calc. Now I will run the quadratic regression, hit Enter, it pastes it to the home screen, hit Enter again, and there you have it. There's our equation. So y equals a, and it says here a equals -2, ax squared plus bx, says b is 6, plus c, 42. So very good. Let's go ahead and write that down. So I'm just copying off the calculator screen here. Y equals -2x squared plus 6x plus 42. And as you can see, that's exactly what the calculator gave me here. There's our A, which was right there. There's our B, which is right here. And there's our C, 42, which is right there. Very, very good. Okay, let's keep on going down here. Good old Skip. Skip shoots an arrow into the air. The equation, -8x squared plus 32x, represents the height of the arrow in meters. Hold on, did we solve 13? Did we get on the regression equation? Yeah, okay. So we're graphing height versus time again. So what is the maximum height of the arrow? Okay, I'm going to use the calculator to do this one. I'm going to type in our function, -8x, oops, -8x squared plus 32x plus 32x, okay? And so let's see what happens when we press graph. Anything? Okay, well, there's our parabola. Let's get a good zoom window. So I'm going to press zoom, and then I'm just going to see what zoom fit gives us. Zoom fit is all the way at the bottom. Did that give us anything? Yeah, okay, that's good. That'll work. So we want to know what is the maximum height of the arrow. All right, so what is important to see here is that here's our maximum. It's somewhere right there. And at our maximum, there will be an x value. Oh, that is not an x. There will be an x value and a y value. Remember, x is time. Don't forget this. X is time, y is the height. So when it says, what is the maximum height? What is the maximum height of the arrow? After we find the max of the parabola, that the y will give us that answer. And then when we say, when is the arrow at this max height? That's when x will give us the answer. So we're going to put the y answer here and the x answer here. So let's go ahead and do that. Alright, so again, we're just going to use our max function, and that works the same way as our zero function did earlier. We'll press second and then trace to bring us to the calculate. Then we'll just do max. Then we'll set a left bound that's left of the maximum, and then a right bound that's right of the maximum. So let's go ahead and do that. Second trace, I will arrow down to maximum. Okay, I'll move my cursor to the right, to the left of the maximum. It's asking for a left bound. Enter. Then I'll move that cursor, where is it? It's slow, come on. Then I'll move that cursor over to the right of the maximum, hit enter, take a guess, and calculator's thinking. There it is, maximum is 2, x equals 2, so it took 2 seconds, remember, time is x, it took 2 seconds for the arrow to go 32 meters into the air. So what is the maximum height of the arrow? 32 meters, and it took 2 seconds for it to do this. Question 3, when will it hit the ground? Ah, very good, very good. Well, we know that if we shoot an arrow into the air, that as time goes by, its height first increases, then the height decreases until the height gets to 0. So we want to know how long, what duration of time passed since us shooting the arrow and then when the arrow hits the ground. So this is what we want to solve for. We want to solve for this x, so in other words, that 0 right there. And so what I'm going to do, so we can get a little bit better look of what that looks like on the calculator, I'm going to do a zoom, I'll do a zoom in. So I'll press enter, and I'll move my cursor to where we want to zoom in at, so you can kind of see the cursor blinking right there. I'll hit enter. Okay, and there's our arrow with our nice 0 right there. So let's press second, calc. We'll go down to 0 just like we did earlier. I'll set a boundary left of the 0, hit enter. Then I'll set a right boundary to the right of the 0, hit enter again for guess, and there we go, 4. So x equals 4. We interpret that to mean 4 seconds. So technically, when it will hit the ground, 4 seconds. 4 seconds after it is fired. Hold on, let me make sure. Well, we'll just say at time equals 4 seconds. Just say at time equals 4 seconds. That's fine. All right, let's keep on trucking. Number 15, the graph. The graph represents the height in feet of a football being thrown towards another player over time. So it looks like our ball was launched at an initial height of 3 feet. So this is like a little pee-wee league. So these tiny tykes are throwing the ball. So it looks like this kid raised the ball above his shoulder, which is about 3 feet off the ground. He threw the ball. It sails through the air. It reaches a maximum height right here at this amount of time. And then it comes down, and it looks like it was an incomplete pass because it hit the ground at 0. So let's take a look at this. So A, at what height was the ball released? Right there, 3 feet. 3 feet. Okay, let me get some zoom action out here. Can we do this? Is this gonna work? Whoa. Okay, at what height was the ball released? We just answered that. What is the vertex of the graph? Now where is the vertex? It looks like that's the vertex right there. And so a follow-up question, that mean, what does the vertex mean? It means it took 1.6 seconds. So it took 1.6 seconds for the ball to reach a maximum height of 6.5 feet. So the vertex is 1.6, comma 6.5. There you go. And remember, this is seconds, and this is feet. Okay, let's move along to part C. What does the very good. What does the x value in the vertex mean for this situation?